So let's look at some examples. Stamp Club has 9 members, including its president, Alicia. Alicia, a 4-person refreshment committee is to be formed. How many committees include Alicia? Well, in order to look at, we want Alicia. There's one, and she wants one. And usually on a committee, order does not matter, so it's a combination. So that's Alicia, and in addition to Alicia, and means I'm multiplying, there are 8 other members, and we need 3. So this becomes 1 times 8 combination 3 is 8, 7, 6 over 3, 2, 1. So that'll give me 56. B, how many do not include Alicia? Well, committees are still combinations. If Alicia is not there, there are 8 people, and we want 4. So that gives me 8, 7, 6, 5, divided by 4, 3, 2, 1. And so when I go through and multiply that out, let's see, 4 and 2 go cancel 8. 3 goes into 6 twice. That gives me 7 times 10, or 70. See how many committees are there altogether? Well, one way of looking at altogether, there are 9 people, and we're going to choose 4. So their combination would be 9, 8, 7, 6 over 4, 3, 2, 1. And so let's see, the 4 and the 2 cancel out the 8. The 3 goes into 6 twice. And when I take 14 times 9, I get 126. Or I could say that there's 56 committees with Alicia, and there's 70 committees without Alicia. So altogether there's 126 possible committees. Now, usually when we talk about permutations, we say permutations can't have repetitions. However, there are some instances where we can compute the number of permutations if there are repetitions. For example, let's look at first how many ways can I arrange the letters of the word dog. As I look at the word dog, I see there's no repeats. And forming words is a permutation. With words, order matters, otherwise spelling wouldn't count. And so I have D-O-G, D-G-O, O-D-G, O-G-D, G-O-D, G-D-O. So that gives me 6 ways. You can also look at it as there were 3 choices for the first letter, 2 for the second, and 1 left, which gives me my 6 ways. Now here, if I look at the word all, with the word all, there are repeats. So if I look at the ways I can do it, I can have A-L-L, I can have L-A-L, I can have L-L-A. And so there are 3 ways, which tells me that there are fewer. And so the way I find the number fewer is there's a formula that says the number of permutations of n objects if R repeat, S repeat, T repeat is given by, we're going to have n factorial, which would be if there were no repeats. And to make it smaller, we're going to divide. We'll divide by r factorial, s factorial, t factorial to get our answer. So if I apply this to all, for all, there are 3 letters altogether, and L repeats twice, and so that would give me 3. If I look at the ways I can arrange the letters in the word Mississippi, altogether there's 11 words. Now there are 4 I's, so I need to divide by 4 factorial. There are 4 S's, so I need to divide by s factorial. And there are 2 P's, so I need to also divide by p factorial. That'll multiply out to a very large number. Instead, if I look at a smaller example, the word people. In the word people, there are 6 letters altogether. There are 2 P's, so I have to divide by 2 factorial. And there are 2 E's, so I have to divide by another 2 factorial. That gives me 6, 5, 4, 3, 2, 1, over 2, 1, 2, 1, which gives me 360 ways. Same idea. How many ways can you run? 4 red flags, 3 blue flags, and 2 green flags up a hole if the flags are indistinguishable except for color. Well, altogether, 4 plus 3 plus 2, there are 9 flags. There are 4 red, 3 blue, 2 green. So that gives me 9, 8, 7, 6, 5, 4, 3, 2, 1 in the numerator, over 4, 3, 2, 1, times 3, 2, 1, times 2, 1. See, 4, 3, 2, 1 will cancel with 4, 3, 2, 1. 3, 2, 1 multiplies to 6. And let's see, this 2 can go into 8 4 times, and so I have 56 times, 63 times 20. So that's going to give me 1,260 ways. Now let's look at some more examples. Let's say I have a jar of marbles. There are 4 red, 5 white, and 6 blue. I want to pick 3 without replacement. What's the probability? Well, because this is probability, I know I need to find a fraction that they're all blue. Well, the first one being blue would be 4 out of 15. Then for the second one, there are 3 blue left out of 14. And for the third one, there are 2 blue left out of 13. And we could multiply. What's the probability I get a red, then a white, then a blue? Well, the red, there's 4 out of the 15. Now, there's 5 white left, but only 14 marbles left. And then there are 6 blue left, but only 13 marbles left. And we would need to multiply that out. Next, let's look at a class of 15 students. Pick 3 to do 3 different problems. Because the problems are different, we're going to say that order matters. So we're going to use permutations. And so for the probability of picking 3 girls, well, my entire sample space, there are 15 students, and I want 3. if I want 3 girls, for what I want in the numerator, there are 10 girls, and I want 3. And so that would give me 10 times 9 times 8 over 15 times 14 times 13. And if I multiply that out and simplify, I'll get 24 over 91. Here I want 1 girl, then 2 boys. My sample space will still be the number of ways I can pick 3 students from the 15. For 1 girl, there's 10 girls. I want 1. And for 2 boys, there are 5 boys, and I want 2. So in the numerator, that gives me 10 times 5p2 would be 5 times 4. And in the denominator, I'll have my 15 times 14 times 13. And this time, when I multiply it out and reduce, I'll be left with 20 over 273. Now, instead, if I want a committee from the class, a committee of 6 from the class, committees are combinations. Order does not matter. And so, if I want the probability of all girls, this time, my sample space is going to be combination 15, 6, and for girls it would be combination 10, 6, and so let's see, combination 10, 6 would be 10, 9, 8, 7, 6, 2, 3, 4, 5, 5 over 6, 5, 4, 3, 2, 1. And in the denominator, I would have 15, 14, 13, 12, 11, 10 over 6, 5, 4, 3, 2, 1. And if I multiply that out in the numerator, I'll have 210. And in the denominator, I will have 5,005. Now, next, if I want a committee with all boys, let's see, there are 5 boys, and the committee has to be 6, so the probability would be 0 because it's not possible. And then, lastly, what would be the probability that that committee of 6 has 2 girls and 4 boys? Well, let's see. My sample space here, I still have a combination, 15 students in the class, and I want to choose 6. And so that denominator is still going to be my 5,005. In the numerator, there are 10 girls, and I want to choose 2. And there are 5 boys, and I want to choose 4. Oops, this should be a C there for a combination. And so that, when I take 10 combination 2, I'll get 45. 5 combination 4 will give me 5. And so this one will be 225 out of the 5,005. Last page of the notes, just some properties of probability that I think are very important. Probability is 0 if something cannot occur. Probability is 1 if something always occurs. So here, if I'm looking at a probability, for probability, the answer is always a fraction. What you want to remember is if a question instead asks how many ways, this time my answer will be a whole number. If two events are mutually exclusive, the probability of A or B is the probability of A plus the probability of B. For events A and B, the probability of both is the probability of the first times the probability of the second, given the first occurred. If two events are not, I missed this one, mutually exclusive, the probability of A or B is the probability of A plus the probability of B minus the probability of both. And down below, if two events are complementary, the sum of their probabilities is 1, or another way of looking at it is the probability of an event is equal to 1 minus the probability of its complement.